Hi all, hope you all are doing great. Well, in this video, we are going to solve problem of the day on the GeeksforGeeks platform. So today's problem is Ceil in BST, right? So as usual, first of all, we'll be understanding the problem statement, then the logic part, and then we'll be proceeding to the coding part, right? So let's get started with the problem statement. But before proceeding further, make sure to subscribe my channel. It will really motivate me to create more such content for you. And please do join our Telegram community as well so that you can stay updated with all the job opportunities and other content that we are putting on our channel. So with that note, let's get started with the problem statement now. So the problem says given a BST, that is a binary search tree, and a number x, you have to find Ceil of x. Now what do you mean by Ceil of x? So that is what they have defined here, that Ceil of x is a number that is either equal to x or is immediately greater than x, right? So now let's have a look on the example. So here's the example one. So x value is here 3, right? So you can see in this tree itself we are having that value 3. So that's what they have defined, that Ceil of a specific number is either is a value that is either equal to x itself or is greater than that of this particular value x, right? So here you can see in the tree we were having 3 itself, right? So this will be our answer. We find 3 in BST, so Ceil of 3 is going to be 3. Okay, so here's the next example. So here x value is 6 and we're having the output as 7. So here you can see in this tree we are not having 6. Then what is the immediate value greater than that of 6? That is 7, right? And that's what we are having here. We find 7 in BST, so Ceil of 6 is what? 7. Whatever task is that we have to complete the function find Ceil to implement Ceil in binary search tree, which returns the Ceil of x in the given binary search tree. Now expected time complexity is bigger of height of the BST. Expected auxiliary space is bigger of height of the BST, right? So I hope the problem statement is clear for you. Before proceeding further, first of all, let me explain you about binary search tree. So what it is, like if we are clear about the property of a binary search tree. So here you can see the root node or the parent node. What is the thing that it does have? See, here we are having the right child as well as the left child as well as the right child. So left child is going to be smaller than that of the parent node. The value of the left node is going to be smaller than that of the parent node, and the value of the right node is going to be greater than that of the parent node. Here you can see the scene. So here if you will see, this is the parent 10. The left child is smaller than that of 10 and the right child is greater than that of 10. Similarly here also if you will see, so this is the parent, 5 is the parent, right? So the left child is smaller than that of the parent and right child is greater than that of the parent, right? Here also you can see it is not having left child, even though the right child is 8, which is greater than that of 7, right? So I hope this property is clear for you. So that's what we have to check here, right? See, the Ceil value of a number is going to be what? Either it should be equal to that of number or greater than that, right? So what we'll check here, for example, let's understand with the help of this example itself. So here the key that we are having, the value that we are having, that is 6, right? So if you will compare this 6 with this 10, so this can be a potential answer, right? Because 10 is greater than that of 6, right? So we'll store this to some variable, right? Now see, 6, whatever main target is, we want to look for the immediate greater value, right? Immediate greater value, right? So obviously we're not going to explore in the right side, because whatever will be the value in the right side of the parent node, that would be greater, right? So we'll explore in the left part, so now we'll see 5. So 5 is greater than that of 6, so it cannot be, it is not going to be the Ceil value, right? So we'll explore in the left side or right side, you tell me. Obviously in the right side. Why? Because see, in the left side, whatever would be the value, that would be smaller than that of the parent node, right? So we'll explore the right portion. So now here we have 7. 7 is greater than that of 6, right? So we'll update the value. So I was saying that, like, first in some variable we store the value 10, because that could be a potential answer. Now 7 is even smaller than that of 10, and we are looking for a smaller value, basically immediate greater than that of the key that we are having, right? So now we'll update the value with 7 and we'll explore further. So now we have the potential answer value as 7, right? Now just tell me whether we are going to explore in the left side of this node or right side. Obviously in the left side, right? Because see, the value 7 that we have got, right? So that is greater than that of 6 itself, and we are looking for a immediate greater value, then why we should explore the right? Because the right value is obviously going to be greater than that of 7 that we got, right? So if you will check in the left side, so this node is not having any left child, right? So it is null. If it is null, then simply what we're gonna do is we're gonna break the condition. Basically we'll be following a loop, so we're gonna break this particular loop, right? And what would be our answer? 7 would be our answer, right? So I hope that you must have understood the logic. So that's what pretty much that we have implemented here. So let's have a look on the code, right? So if the root value is null, then simply you have to return -1, right? And this is the variable to keep track of the potential answer or the Ceil value, right? So for now we have initialized this with -1. If key value that we have that is equal to that of the root node itself, the value that we do have root node itself, then simply return that key, right? You don't have to explore further. Otherwise what we're going to do is we're having this loop till the time root value is not equal to null. So if key that we are having, if it is greater than that of the data of root that we are having, then obviously where can be your answer? In the right side, right? Because key is greater than that of the value that you came across, so we'll explore the right portion of the tree. Otherwise, okay, this is not needed. Otherwise what we'll be doing is we'll be updating the value of Ceil first of all with the root dot data, because that can be a potential answer, and we'll be exploring the left portion, right? So we'll be updating the value of root as root dot left, and at the end we are simply turning Ceil value. Okay, so that's what the complete code was for the given problem. So I hope the problem statement, the logic part, and the code is clear for you. I have provided the code in the description for the reference, so you can just check it from there as well. Thank you so much for watching. Keep learning. Bye bye.